ones you see right here in front of you, where it's not just sine of theta or sine of x or anything like that, but it's got something else with it. 2 theta, for instance, or theta over 2. But it could be, those were the main ones that we've done. But it could be 3 theta, it could be, 2 theta over 5. It could be any coefficient of your angle. If your angle has a coefficient, because theta is your angle, but if there's a coefficient, remember this is the same as if it said 1/2 theta. That's the exact same thing. So in other words, that's a coefficient of 1/2. Okay? So if your angle has a coefficient, because when we get our answers, we'll be getting rid of that coefficient, that changes where we should be looking for our possible answers. Okay, there's an example on the board right now we worked on yesterday. It was from 0 to 2 theta. And basically because of this 2, we ended up having to look from 0 to 4 theta because we're going to divide by 2. So values that are even more than one rotation around, once you divide by 2, are between 0 and 2 theta. So here's how, this is what I consider the most efficient way to deal with these. And that is to turn off that alarm, sorry. Okay. And that is, first of all, think about this. It might be easier, well, you can leave it in interval notation if you're happy, but I tend to think of this as an inequality. And if your angle is not by itself, if your angle has a coefficient, then basically take that and say, I'm going to multiply all the way through that by the coefficient. In other words, 2 times 0, 2 times theta, 2 times this. So in other words, this says that 0 to 2 theta, well, that 2 theta is between 0 and 4 theta. In other words, if we want an answer, if we want theta to be between 0 and 2 theta, then 2 theta, which is what we're dealing with right now, has to be between 0 and 4 theta. So we are finding all values for which the sine is -3, square root of 3 over 2, all the way up to 4 theta. Because right now we're dealing with 2 theta. So for 2 theta, we have to look from 0 to 4 theta. Okay, so all the values for which the sine is -3 root 2, negative root 3 over 2. Well, sine is negative root 3 over 2 down here in the bottom. So in the third quadrant and the fourth quadrant. But remember, this is one rotation, so that's up to 2 theta. So if we go around again, then you could think of it as down here again and down here again. So right here we have sine. So 4 pi over 3 is the first place that the sine is equal to negative root 3 over 2. 5 pi over 3 is the next place. Okay. Now these blue lines here, this is thirds. In other words, this is 0 thirds, 1/3, 2/3, 3/3, 4/3, 5/3. That's what 4 pi over 3 is. 4/3 pi, 5/3. So if we go around again, because we're going all the way up to 4 pi, this is 6/3, 7/3, 8/3, 9/3. So it happens again at 10/3 and at 11/3. This would be 12/3. So you can think about that. You can count your way around the unit circle to see where does this happen between 0 and 4 pi. Or another way you could do it is you could say, okay, just in one rotation of the unit circle, it happens at 4 pi over 3 and 5 pi over 3. So that happens at 4 pi over 3. It happens at 5 pi over 3, but that's only going around once. If I have to go around another time, then I'm going to add 2 pi to this, because all the way around a circle is 2 pi. If you add 2 pi to this, that's the same as taking 4 pi over 3 and adding 6 pi over 3, because 6 over 3 makes 2. And taking 5 pi over 3 and adding 6 pi over 3, because that means I'm going around one more time. So in other words, this also happens at 10 pi over 3 and 11 pi over 3, which is the same thing I got if I just counted my way around in terms of thirds. In other words, it happens, this is 1/3, 2/3, 3/3, 4/3 it happens here, 5/3 it happens here, 6/3, 7/3, 8/3, 9/3, 10/3 it happens here, 11/3 it happens here. When I say it happens, I'm saying sine is equal to negative root 3 over 2. So those are the 4 times it happens between 0 and 4 pi. And then we get to solve for actual theta. These are when 2 pi is going to be equal to those, or 2 theta, excuse me. When 2 theta is going to be equal to, when the sine of 2 theta gives you this value. So now we have to solve for theta. We just divide everything by 2. Dividing by 2, remember, is the same as multiplying by 1/2. So you could think of it as that, since we have fractions. Okay, so my answers are 4 pi over 6, which reduces to 2 pi over 3, 5 pi over 6, which does not reduce, 10 pi over 6, which reduces to 5 pi over 4. Nope, 5 pi over 3, sorry. And 11 pi over 6, which does not reduce. Those are my answers. We don't have to do the plus 2n because it said in this interval. If it had just said all values, that's when you do the plus 2n. Yes, ma'am. To try and get theta by itself to solve. Because what we're doing ultimately is finding all values of theta for which this is true. So we have to get theta by itself at the end. Okay, so I'm going to go ahead and sort of cordon this off and say, why don't you try number 2 here? Start out with this and take the coefficient of theta and multiply it through to see where you need to be looking for answers. Okay, so first thing I did here was say, okay, if theta has to be between 0 and 2 pi, then let me take this coefficient and multiply through, and that means that 2 theta has to be between 0 and 4 pi. Okay, so we're looking for all the places between 0 and 4 pi that cosine has a value of negative root 2 over 2. For cosine to be negative means you are going left. So cosine has a negative value in the second quadrant and then the third quadrant. So this is at 3 pi over 4, which is 3/4 of pi, 4/4, 5/4 of pi. So that's between 0 and 2 pi. It happens at 3 pi over 4 and 5 pi over 4. But we're going between 0 and 4 pi, so that means we're going around again. So this is 3 pi over 4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 is the same as 2 pi. 8 over 4 is 2. 9/4, 10/4, 11/4, 12, 13/4. So at 3/4 of pi, 5/4 of pi, 11/4 of pi, and 13/4 of pi. The other way you can think of that, other than just kind of counting your way around the unit circle, is 2 theta is 3 pi over 4. 2 theta is 5 pi over 4, or just like we did right here, we can say 2 theta is either of those values plus 1 rotation around the circle. So 3 pi over 4 plus all the way around is 2 pi, so that's 8 pi over 4. 5 pi over 4 from here plus all the way around is 2 pi, so that's 8 pi over 4. So this makes 11 pi over 4, just like we got counting our way around, and this makes 13 pi over 4. Okay, so now there's only one thing left to do, and that is find the value of actual theta. We know what 2 theta has to be, but we haven't solved for theta. To solve for theta, we get rid of the 2. Multiply by 1/2 is the easiest way to do that when you're dealing with fractions. So our values are 3 pi over 8, 5 pi over 8, looks like we won't have to simplify, 11 pi over 8, and 13 pi over 8. Did you guys get this? Awesome. So those are your 4 answers. Okay, so those both had coefficients of 2 on our angle. Let's look at when the coefficient is 1/2. Okay, so sine of theta over 2 equals this. Now we're going to start out the same way. We're going to say, all right, if we need to have theta be between 0 and 2 pi, which is what the directions told us, then 1/2 of theta, which is what this says, means I have to multiply all of these by 1/2. And 1/2 of theta needs to be between 0 and pi. So we're only looking for answers between 0 and pi. Why? Because to get rid of the 1/2, we're going to be multiplying both sides by 2. And we still have to stay less than 2 theta. Less than 2 pi to be in this interval. Okay, so places where sine is equal to positive root 2 over 2. Well, right here and right here. So if we're going 0 to pi only, those are the only 2 we need. So pi over 4, 3 pi over 4. Those are my 2 answers. Okay, so theta over 2 equals pi over 4, or theta over 2 equals 3 pi over 4. And now we just have to solve for theta, multiplying both sides by 2. To get rid of a 1/2, multiply by 2. It's the same as multiplying by 2 over 1. These cancel, and we have theta equals 2 pi over 4 is 1/2 of pi. 6 pi over 4 is 3 pi over 2. And those are my answers. Questions on that one? All right, now you get to try. Okay, so we're starting out the same way. We're saying if theta is supposed to be between 0 and 2 pi, then that means that 1/2 theta needs to be between 0 and pi. Okay, so we're looking at all the places on the top half here between 0 and pi that cosine is negative root 3 over 2. So 5 pi over 6, that's it. Just 5 pi over 6. Okay, so theta over 2 equals 5 pi over 6. Get rid of the over 2, which is the same thing as times 1/2, by multiplying both sides by 2, so that theta will be alone, and we get 10 pi over 6, which reduces to 5 pi over 3, and that's our only answer. Did you get it? Awesome. The directions tell us you're being asked 0 to 2 pi. If you have a coefficient, you multiply that times the coefficient. And that's where you look, between 0 and whatever your coefficient times 2 pi is.